For problem 4.3.5, the Lewis structures of these organic molecules vary from straightforward to a little tricky. So let's start with methane, CH4. The C goes in the middle, surrounded by 4 H's. And that's it. If we were to count the valence electrons in CH4, carbon gives us 4, each H, there's 4 of them, gives us 1. That's 8 valence electrons total. Remember, hydrogen's satisfied just having 2, and carbon has 8 with those bonds all around it. So that would be the Lewis structure for methane. Now, for ethylene, C2H4, we again put the carbons in the middle and the H's on the outside. And this is because the H's can only bond with one thing. So to put them in the middle doesn't make much sense because they can't form more than one bond. Each carbon gives us 4, but there's 2. And each H gives us 1, but there's 4. So altogether that's going to give us 12 valence electrons to work with. I've used 2, 4, 6, 8, 10 to connect everything with a single bond. So that leaves us with 1 pair left over, which if I did that, only one of the carbons would be satisfied. So I'm going to have to make a double bond. And the only place I can make a double bond is between the 2 carbons. Now you may be saying, why did you put 2 H's on each of the carbons? Why couldn't you have done something like this? That would have been 2, 4, 6, 8, 10 electrons. I only would have had 2 left. And I still could have only made a double bond between the 2 C's, which would not leave the second carbon satisfied. So it has to be a double bond with 2 H's on each of the carbons. For ethane, C2H6, we're going to again put the C's in the middle and surround them by H's. In this case, I have 6 H's, which means there's going to be 3 on each carbon. 2, 4, 6, 8, 10, 12, 14 electrons were used, and I should have counted before we started, but I got ahead of myself. But the good news is I had 14 valence electrons to work with, so I've used them all. Everything's connected with a single bond. Everything has the number of electrons at once, either 2 or 8, so that is going to be the Lewis structure for ethane, or ethane. Propyne, now propyne and diacetylene, the last 2 that were given, are given to us as structural formulas to help us visualize how they're bonded together. So propyne is 3 C's bonded together with an H on one end and 3 H's on the other. So that gives us some clues on what else we're going to have to do to bond these things together. But let's go ahead and count our valence electrons real quick. 3 carbons each have 4. And 4 H's each have 1. That's going to give me 16 valence electrons total. I've used 2, 4, 6, 8, 10, 12 of them so far. So I have 4 left to use. And I'm going to need to somehow get both of these C's up to having 8. So if I just did 1 C to start with, that would satisfy that middle C's octet, but the right-hand C would only have 4 electrons instead of 8. So what I'm going to have to do is I'm going to have to take one of those lone pairs and turn it into a double bond between them. That still leaves the middle C with a full octet, and this right-hand C is now up to 6. So I am going to have to go ahead and take the other pair off and actually form a triple bond between the 2 C's, so that both of these C's have 8 electrons. Everyone is satisfied, and that's going to be the structure. Now the last one, diacetylene, also a structural formula. It's an H bonded to a C, bonded to a C, bonded to a C, bonded to a C, bonded to an H. So 4 C's with an H sort of capping it off on either end. If I use those 4 C's, each of them give me 4 electrons plus the 2 H's. Altogether, I'm going to have 18 valence electrons that I can work with, and so far connecting everything with a single bond, 2, 4, 6, 8, 10 of them have been used, so I have 8 left. So we can just start 2, 4, 6, 8. So I've gone ahead and I've completed the octet, but 2 of my C's only have 4 electrons each, so I'm going to have to redistribute some of these electrons. We can start by moving one of these electron pairs and making a double bond, but when I do that, this C now still has 8, but this C suddenly has 10 valence electrons, which is a red flag. I can't do that. So I'm going to go ahead and move one of these lone pairs and form another double bond with the C next to it. But that still leaves me with 10 electrons on this C, so even that's no good. I actually need to move that pair over to one of these C's. And now I have 8, and I have 6 and 6. So what I'm going to need to do is I'm going to need to move these lone pairs again. Go ahead and move this one off. I'm going to make a triple bond here, and I'm going to move this one off, and I'm going to make a triple bond here. Now, like I said in the problem, this one is a little tricky. It's okay if you didn't get it right off the bat. I wouldn't expect you to. I wouldn't give you something like this on a quiz. But this is probably one of the more challenging ones I've asked you to do, and it's a good exercise of where those electrons need to go so that everyone has an octet and we only use the number of valence electrons we have available to us.